Okay, so we're talking about here our ontology tradecraft class. We're talking about how to, make this stuff apparent to me that you're changing in your repos. And so Sam was asking about opening pull requests when it changes. What does he have to do? Should he have to open a pull request get based on his setup? And so what I'm going to do is I'm going to look over here in Insights. This is my repo, the base one. I'm going to check out these forks. And I'm gonna look for the folks who have forked the repo. So do you see yourself here, Sam, anywhere?
Yeah, it's GTR Sam, kind of in the middle.
Or Sam, got it. Okay, so what I'm gonna do is I'm gonna click over here. I'm gonna check your stuff out, and then okay, so this should be what you see when you're in your repo, right? So you should have this. This is because this is your repo, right? This should be
Yep.
exactly what you're seeing. Okay. And so what you've done is you've recently like forked this over. It looks like 6 hours ago. It's awesome. Now, um, you are currently, you see right here, you're one commit ahead and one commit behind. Now, I think I know why you're one commit behind, and that's because about an hour ago, I pushed a bunch of changes to the repo. So I'll just show you what that looks like. I made a bunch of things. I added a link for a video and I made a bunch of changes to Project 4 or updates to Project 4, which you don't have because you forked before that. It's totally fine. I just want to highlight like that's why it's saying that you're behind. At some point you'll want to like update, like, as you know. Now to on the other hand, so it looks like you were playing around in VS Code or here you said VS Code and you pushed to your repo here on GitHub, through your terminal or however, and then it's saved on the repository here. And that because I don't have access to that yet, it's saying that it's one commit ahead. And so when you click on that right here, you've got one commit ahead. You're making changes to project one, and then you've done your thing. Now you have this opportunity to create a pull request. I could actually come in and create a pull request. Isn't that crazy? Like I could do it. I'm not going to. I'm gonna let you do it. But you'll create a pull request, and what that'll do is it will alert me. And I'll just click back over here. It will let me know right here that you have created a pull request and I should check it out. And you'll see there are a bunch of pull requests that have been made by folks in class. So just so you know how this will roll out, you'll open a pull request. I'll see it, and then if I can, if it doesn't have some kind of conflicts, then like this one. So Tim, one of your peers here, has created a project one and project two. When I see it, I'm going to be able to approve workflows to run. And so all those auto grading and testing stuff that I have, I've got a bunch of Python tests that are kind of checking out your work. I just go ahead and click that, and all those tests start running. And then it's going to tell me for Tim, Tim's not here to defend himself either. Thumbs up, thumbs down, and it should go pretty quickly. We'll see, fingers crossed. But I'll do the same when you open a pull request for mine. Now, traditionally, like typically, you open a pull request on my repo, the main repo. If it's great and cool, then what I'll do is I'll merge it in and make changes to my repository. I'm not doing that here because it's class and I'm like keeping the project page clean. Plus, I just have like a bunch of solutions like fun it up. Nevertheless, we can still keep track of them because they're PRs and so they're all public. Everybody can see them. And you see right here, that's what I'm talking about. All the checks have passed. I could just merge it in. That would change my repository, and then everybody who forks from it would get those changes too. Everybody would get Tim's solution. I don't want that. And so what I've been doing is just now that he's good, making a note, closing the pull request, and Tim has completed project one and two. And that's what I'll do when you send yours over and it passes the tests. And so in answer to, I know, I apologize, that was a long-winded answer. You were like, should I open a pull request? Yes. But I definitely want to make sure like that's kind of the, why, like explaining why and how you see it. Because I think that kind of like commit ahead can be overlooked easily. But that's kind of where it is. Like one commit ahead, you can make a pull request.
Okay, no, that help. That's very helpful. So now I think I get it, right? once you clone the repository on your computer, you make the changes on your computer. If you're working directly in Git, it'll go to the owner of that repository, in this case you. But if you're working in a VS Code, Anaconda environment of some sort, it'll push it to your repository, and you still have to go create that pull request. So
Yeah.
commit and push is to your local, and
Mhm.
then the pull is to the whatever the main project. Okay, got it.
Yeah. And I mean, there are like, that's how this is set up. If you had like when you're making changes to your own repositories, like, the way I make changes to the main repository, like I don't need to open a pull request. I just like push
Go
it.
in and do it
Yeah.
or push
I
it. Yeah.
also don't have to do it in VS Code. I can just go in, like I can do it right here. I can make changes. Ain't nobody gonna tell me nothing. You're not gonna stop me. I'm gonna change it right now. Like I can do that without having to open a pull request too, and also without having to push something from VS Code or from my local device over because I'm just doing it right here in the browser. Yeah,
Okay, got it. That answers it.
awesome, great, cool. What else we got? You guys want to talk about the zebra?
Sure, let's talk about the zebra puzzle because I was
Lovely puzzle.
struggling with that one as well, just
Lovely.
getting it to work
It's a toughie.
in Protege specifically.
Mm-hmm. So, Mike, you want to start us off? You had some comments on it.
Yeah, well, I don't know about comments, but I can show you what I have.
Yeah, let's do it here.
Not a whole lot, but
I swore that if anybody actually solved this, I'd give everybody else a harder problem in the future. And Austin solved it, so sucks for everybody else. It's like,
uh, again, I don't know if I'm doing this right, but I created like from thing animals, then I put in the animals that were there, beverages, which something I was going to ask you, John, is on the example, like when you were doing the classwork, you had water in there, but I never saw water in the the questions. So is that something we have to infer, or
oh, yeah. So there is, yeah. So in the base puzzle, if I remember correctly, water's not mentioned. We don't have to add it in, because there's nothing. We're not trying to find it, but you could technically find out who owns the water too, or who drinks the water. The thing is, like, just like the zebra is not mentioned, when you assert the puzzle, like the conditions of the puzzle correctly, everybody has to own something. Everybody has to drink something. Um, the zebra's not mentioned, and so by process of elimination, whoever's not owning something at the end has to own the zebra. Similarly, by process of elimination, whoever's not drinking something has to drink the water, and water's like the placeholder. But no, technically, you don't have to say anything about that. You don't, you're not creating a class for the drinker or for water or something like that. Although you could. I mean, it would work just the same, like deduction and all the same. Like in fact, if you set the puzzle up to solve the zebra or to answer who owns the zebra, you should be able to also answer who drinks the water.
yeah, not that advanced yet. But so and you, I think you had this listed a little differently. I put house position. Um, I didn't know how to necessarily label this
Hmm.
because the house is the thing, but
Hmm.
we're referencing the position of the houses.
Are you meaning to share a screen?
Is it not sharing?
I'm not seeing it. I mean, I'm
Uh, I,
seeing your glorious mug, but I'm not seeing this.
I see the screen.
Oh, you do see the screen. Okay, I'm just
Now he just stopped.
okay. I'm
Now I
sorry.
don't.
It was a me thing. Maybe I was just lucky.
Uh,
All right, Mike, if I missed that.
I'm trying to get back to where I need to be here. Hang on. All right. Can you see my screen?
Yes, sir. All right, so here we go. So you've got peppers and animals, beverages. Yep. All righty.
So this was what I was kind of talking about. Like
Hmm.
I didn't like the way this kind of came out, but I wasn't sure how else to do it.
Hmm.
Because the house is the thing,
Hmm.
but all we really know about the houses is there's five of them. So I don't know, would have been make more sense to just list house one, house two, house three.
Yeah, there's one thing though to just jump in here on. So you've got you've got classes for things like tea and orange juice and red and yellow. But these are, for the sake of the puzzle, going to be instances of things.
Okay, so like the colors would be instances.
Yeah.
Because I have them all in individuals.
Hmm.
So where would I put, I guess, instances?
Under individuals. But like I saw that you had, classes for things like, orange.
Right.
Yeah. But you
So
don't actually need that. So you have they're all beverages, right? Like, but you don't need like orange juice as a class. Because there's a specific orange juice that's being drank, right? And part of the reasoning here is like, when we're introducing classes, it's true there are multiple instances of the class orange juice. That is absolutely true. But here we don't need that kind of, flexibility because we know which specific orange juice we're talking about. Like it's that one, like the orange juice over there. And the more of that kind of like specification you can add into the puzzle, the easier it is for you to infer information. So if we just knew like some orange juice is being drunk, but not a specific one, we can only infer so much information. But if we know that specific one is being drunk,
so I basically get rid of all of those.
yeah, yeah. So yeah. So you don't need those. So like coffee, and it looks like you've got a coffee individual, right? And what it looks like what you've done is you've had like a class coffee and then you had an individual coffee. You could
Okay,
just
so
lump all of those up into beverages because we've got all that specific information.
I essentially, I guess, duplicated work on that.
Yeah, a little bit. It's all right. Better safe than sorry, right?
Oh, when you don't know what you're doing here.
Yeah. But I mean, I get your reasoning, right? Like, and hopefully what I'm saying like makes sense. So, like as a general rule, when you're introducing classes, it allows us to talk about sets of things, whether we know the specific things in it or not. But then if we know specific things that we want to talk about, we have this resource individuals where we can just talk about the specific things themselves and then say they're related to other class or parts or types of other classes or stuff like that. So I think of like the distinction here, like formally between classes and instances or individuals is one between like knowing something versus knowing a specific thing. And that can be very useful, a very useful distinction to know. Like I know someone burgled my house. I know Sam did, right? Like, sorry, Sam. Didn't mean to throw you under the bus.
I'll do better. I won't get caught next time.
There we go. That's always my rule. Right? I'm mad because
That's
you
all getting better.
say that again.
So the same deal with the colors. All I
That's
need
right.
is
That's
color
right.
as a class, right?
That's right. And I'll tell you a trick too. So when you're thinking same with colors, same with the houses. And you're right though about that one, two, three, four, five. Like just name that because they don't have specific names. You can say house one, house two. I wouldn't talk about their position because it turns out to not matter for this. What only matters is that they're like situated to the left or right of one another, right? And so you don't really need to put them on a number line. You just need to put them in relationship to each other. Uh, but like the kind of a subtle trick here, which I can show you, I can walk through how to do right now is if you just you click on animals. All right, so then if you I think you'll need to, I want you to add some restrictions on this, but to do that, I think you're going to need to open a window. So if you can go up to window at the top of your screen and click on view, and then click on, let's see, what is it? Class description view, class views. If you click on class views, do you see class description? Okay, description, maybe that's it.
No,
All right. Yeah. If you click that and then you just drop down to the bottom on the bottom right. Yeah, where it's got that. Yeah. Just yeah, right there. Click there. So okay. Wait, did I just have you do the same thing? Okay. You know what? Go ahead and X what I just asked you to do out. I'm gonna edit that out of this recording. I literally just didn't realize that you could do the thing that I was asking. I'm so sorry. I'm sleeping. Okay, no. Drop that. Forget all that. Just go to. God, I'm an idiot. Go to equivalent to at the top right there. Yeah. Okay. Here's what I want you to do. So there's a class expression editor. You see that right at the top? Okay. I want you to type in parentheses, um, bracket, uh, DOJ, so dog. Okay, or DOG. And then next, outside of the that parentheses, you hit a space and just put or, and then do that same pattern for fox, and do that same pattern for horse, snail, and zebra. For some reason, it's giving you an error. Maybe drop the parentheses around it. Maybe that's what's it's giving you the red squiggles. Yeah, keep the brackets, but drop the parentheses.
Is the Windows syntax different?
Is it? Oh, this is so you're using a Mac, right?
yes,
Okay, I'm using a Mac, and that works on mine. Do you have? Oh, you have. I meant. I'm sorry. Did I say brackets? I meant braces. So like the
like the
square braces.
curly brace.
Yeah, yeah. I apologize. Okay, there we go. That's what I mean. Okay, so just braces around, and then it's dog, horse, fox, snail, zebra. Each of the instances. Yeah, that's another way to do it. What Sam has described.
Let's see, horse,
You got
dog.
zebra. That's it. Okay, and then you can hit OK. All right, here's what you've done. Okay, there's where the parentheses came in. I was wondering where okay, here's what you've effectively done. And you can delete those classes under it too. So dog, fox, horse, snail, like you can get rid of not those, not those. Just at the top. Yeah. You can get rid of those classes there. Okay, so what you wait, did it just make them all disappear? Okay, there we go. So what you've done, so you've asserted that animals, and you can see this is an equivalent class. You can see it's equivalent because it's got those three bars next to it in the top. So you're saying that animals is equivalent to dog or fox or horse or snail or zebra. So one of those. So anytime you have an animal, you have one of those, and anytime you have one of those, you have an animal, right? And so those are all distinct individuals. But what you've done is essentially defined the animal's class by enumeration. You said this is all and only the instances that fall in that class. That's very powerful. You're able to infer a lot of information from that. Like I said, if we also get through and assert that one and only one person owns the dog, the fox, the horse, the snail, we don't know anything about the zebra, but we know somebody has to own it, then we know whoever's left over has to own the zebra because everybody else or every other thing from the animals class has already been owned. It's already been named, right? So this is like giving us an additional logical resource to tell the machine like this is exactly the class of things that are owned. People have to own them, and one and only one person can own them, or each of them. Does that make sense?
I think so.
Uh,
And the scripting part, it's going to take me a while to get used to, but and it's simple enough. But
Yeah,
just knowing how to
and you'll do this.
navigate it.
You'll do this too with like cigarettes and the color. All right, and the beverages, you'll do this with each of them, or tobacco, you'll for yours. You do it for each of them. You can enumerate, and you're effectively like defining the class in terms of all and only the things that can fall into it, the instances. So things like, for color, it's blue, green, ivory, red, yellow. You'll do the same thing there.
Okay, so for all of my main categories, and I just get rid of all these secondary.
Yeah, you won't need those. They're just kind of getting away. They might still work. I'm not um trying to think. It may or may not work. There may be some subtlety in the existential, but I know enumerating the classes or the instances will work.
Okay,
Mhm.
all right.
Mhm.
So, and I tried like disjoining, I guess. Some of those like
Mhm.
coffee's not the same as milk. I tried doing that, but I don't know if it was necessary. Like,
Uh,
does it? I still,
I did it. I did it. If it's disjoint, it's disjoint. Although you can, there are a couple of ways to get disjointness here. You can do it at the class level and say these classes are disjoint, which case, no instance of pet is an instance of man. You could also do it from the ground up, maybe from the instance up by just asserting that every instance is distinct. And you can do that by going in the individuals. And you can, if you go to, where is it? It's like, just assert that they're all distinct. Oh, yeah. If you go to edit right at the top of your screen there, and you see make all individuals different.
okay,
Yeah, you click that and that's true, they are. This just asserts that all of the individuals are distinct. And that is effectively a way to make the classes disjoint because you're saying all of the classes are like basically characterized in terms of like by grouping five different things, and they're all different. So
okay.
there's no case
So I
of
wouldn't need to individually go through and
that's right.
label each one as being
It would
different.
be it would be infer yeah, you've effectively done that here, and then you also don't need to go back and say that the classes are disjoint because they have to be, because all the instances are different and all the classes are defined in terms of like groups of five of these things, distinct
So
group.
so I have a question. I made all the classes distinct or disjoint, and
Uh,
then it just told me it couldn't compute the ontology, and I'm doing it now on mine, and it's the first time I did it at the class level,
mm,
and I got a bunch of errors saying
mm.
it's like not possible, I can't solve it. And now I'm doing it and it's not finding any explanations. I just did made all the individuals unique, like you just explained.
Yeah.
So
Interesting. I'd have to debug, right? Like I'm not sure what
okay,
went wrong. But
got it.
yeah, the logic should work as I just said for sure.
Okay.
Yeah, and it should certainly make them all distinct because they're all enumerated, right?
Yep.
I'm not sure why it wouldn't. Let's see. Sometimes, yeah. What exactly did it say about not being able to compute? Like it usually will give you some suggestion of what went wrong.
Do you want to share screen? Like I can stop
Sure.
sharing.
I have well, since I hang on, there it is. Share screen. I got a lot going on here. No, there we go. It doesn't like my so you can see it's just right now I made everything distinct at the individual level
Yeah.
and Protege doesn't like me.
I see.
Won't let me do anything.
Let's see
Won't let me
what's,
move it.
let's see.
Hang on. Let me do
Oh,
something
it's
really quick.
computing explanations. I see.
Yeah. It's just
Mhm. Yeah, sometimes it'll crunch for a minute. Um, did it say that something was, did it say there was an error? It was trying to identify explanations for it?
not not at the individual level because it said computing explanations found 0, but when I did it at the class level, I made them all disjoint. It gave me like a bunch of errors,
Interesting.
like 37, like it just kept computing errors. So I did
That's
some
good.
like I I think I stopped at it for like 37 or something.
So I've got mine up now just for what it's worth, and my solution, and I both have them asserted as disjoint classes and as the individuals being distinct, and I'm not getting any errors. I don't know
Hmm.
why it's I'm sure mine's efficient though. It's a pretty quick crunch, so it doesn't take long, and I don't know what computer you're running or what processing power you have. Let's see. Not exactly on man. Let me see beverages. hmm
So I don't have anything exactly crazy in here. I think the syntax is good. I got all the restriction, the equivalent, the
Well, I bet I know what's going on. Okay, so cardinality restrictions, the exactly restrictions, they do take processing power.
mm,
I have,
okay.
and look over at your object properties real quick. Let me look at how you've got those. Uh, uh, yeah, object properties. Let's see. Can you just pick just maybe drinks or has color? Okay. Okay, so you've got, yeah, it looks like what is that? Has color.
Yeah, it has color, inverse
Yeah.
color of domain house
Okay, so
range.
this might have something to do with it. So like for the instead of asserting exactly because I knew I could infer this, I did what you're doing here with the functional and inverse functional because it's what makes the relationship one to one. But because I knew that I knew I didn't have to say exactly one. So like drink or beverages drunk by exactly one man, like, I didn't have to say that. I could say it was drunk by some man. And then let the object properties and the one-to-oneness do that kind of exactly reasoning. And so what's going on, I think, is that because you have exactly in there, it's basically crunching or processing that one-to-one relationship for each of these instances twice. And,
Mm,
and you could just get by with doing it once because it's inferred, because of that functional inverse functional. I suspect that has something to do with it. That like one-to-one tracking it's powerful, and so it can take a minute. I don't know if I'm not sure if that would cause an error, but it would certainly make the compute time higher, I think. Yeah, so you might just change those exactlies to some and see what happens.
okay, got it. Yeah, because yep, change all those. Okay, I will do that. Do it now here if you want, or you can do it later. Whoops, cancel.
So, like what he's working on right there, that was
Mhm.
one of the things I didn't understand, like how I could write that a person was doing whatever act, drinking the or smoking a cigarette, whatever.
Mhm.
So it understands some or he has exactly their
Yeah.
it pick that up and understands like what that means.
Yeah, so you see that it's in purple. That means it's part of the reserved vocabulary in OWL, so the web ontology language, and it's got you can use only for like universal constraints, you can use some for like existentials, and then exactly means some and only. So it's like it's both of them at the same time. And then these are some of the reserved vocabulary. Same with or. So you used or earlier. That's a reserved vocabulary. It means this one or that one. And you can use and. It means both of these together. But absolutely. And this is kind of how we relate class or like one part of a taxonomy to another by using these only and these some restrictions with object properties. So I but I wanted to just note, so what he's doing here, and you could do this with many of the classes, is you can say things like, cigarettes are smoked by some person, color is the color of some house. Like these are like class level restrictions. So like anything that falls in the class of color is the color of some house, right? So if you have this, if you have the class color is equivalent to blue, green, or ivy, or red, or yellow, that means blue is the color of some house, green is the color of some house, ivory is the color, and so forth and so on. That's at the class level. If you go over to the individuals, and this is kind of closer to the constraints that you're reading off, like the 14 conditions, and you look at something like, Norwegian, I'm sorry, milk, like the beverage milk, like the individual specific milk. You can assert that it is an instance of the type beverage, but then you can also add in that this specific milk is drunk by someone who lives in the third house, right? And it's just you do it just the way that he's doing this. Like you can write in, like you just type in drunk by someone who lives in the third house. And that's going to reflect very closely with those 14 constraints that you have. That's not at the class level, that's at the individual level, which should make sense because when we're talking about like this specific milk, we're talking about that glass of milk, right? Like that milk, not just milk in general. We all know that milk is drunk by somebody. This milk is drunk by whoever that is, the person in the third house.
So here's a question in the syntax. Why? Because the puzzle says like, how does the how does the how does the computer know it's drunk in some, and how does it know? Why would we not have to put something in there to say it's got to be drunk by some man or person, whatever you name the class?
Well, so this will come from if you got put has position. So mine is lives in. And so if I go to, I'm just walking through mine and I go to lives in is the inverse of homes of. Homes of has the domain man and range house.
Okay, got it. Yeah, that makes sense. It's hard to connect some of this logic
Right,
sometimes
right.
with the separating the logic from the syntax, and depending on which program or
Mhm.
software package you're using, the syntax is different.
That's right. That's right. That's why we're trying to, absolutely right. We're trying to create a logical foundation for all of that shit. It's, yeah, yeah, it's hard.
Okay.
It's hard, but hopefully you can see that chain, right? Like that's kind of how it works. And you should always be able to, this is one of the beauties of logic. You should always be able to answer the questions like the one you just had said. Like, how does the computer know that it's the guy, a man? Well, you bet there better be a chain because that's the only way the computer's going to know because computer ain't going to be able to infer it its own. All right, so you're building the class hierarchy. Should be faster.
It's not.
Oh no. It might just take a minute.
I'm not using the slowest computer, but not using some supercomputer either.
Man, mine's not super either. Sure, there's some other subtleties here. Let's see.
Yeah, I'm sure there is too.
Yeah.
Yeah, and I don't know if so. The other thing I didn't do is in the class position, I got first, middle, left of, right of, like, but I didn't have any instances of this. You can see I didn't
Yeah.
populate that. I don't know if that matters or not. Probably
Let's
not
see.
for the reasoner, I guess, but
Um, so I didn't actually need, so that might, I'm sure that's a complicating factor because I didn't find any need to use the positions. So when I was reading the puzzle, it occurred to me that, um, like, like a numerical positioning of the houses, was not really entailed by the constraints. What was entailed is relative positions, the to the left of, to the right of. And so I didn't need to say one through five like in the logic. I did list the house one, house two, house three, house four, five, but that was like that was just the names of the instances. Like the logic is it doesn't reflect that. The logic reflects that one house is next to the other, stuff like that. Let me see what I said exactly. Like house one is to the left of nothing. House two didn't say anything about oh wait, no, I did. I said it's to the left of house one. I did say house three was to the left of house two, and house three was to the left of house four, and house five was to the left of house four. And then I said that house five was to the right of nothing. And then I didn't need to say anything about the positions then, because I just kind of like, so I didn't have a class for positioning. I just
okay.
had this house was the left of this house, and the left of that. And then I said, on the ends, I just said there is nothing else. And the way you write that is just like house five is to the right of exactly zero owl things.
I think I changed my perspective on this one because I got right of house four,
Mhm.
which it would be if you're looking at it.
Yeah, this happened last time I was teaching this. I think Giacomo was like, mine's the other direction. I'm like, I don't think it matters, but yeah, because we were talking past each other for a second.
Okay,
But
I'll switch these up too. I I have to. I'll switch these up too and keep going through this, figure out how this works. But as long as I have the positioning values in a object property, right of, left of, next to is the other one. Why don't I have next to in here? That might be a problem. Yeah, okay. I gotta add that.
mhm.
Okay. All right, I will keep messing with this
Right.
because I do have to go soon.
Okay.
Got work tomorrow. Kids got school,
Oh, yeah.
all kinds of stuff.
Yep. I get you. Mike, do you have any other questions?
I'll have all kinds of questions, but I guess you've given me a little bit for tonight, anyways.
Okay. All right. Well, good. I tell you what, I'm gonna go have some dinner. And if you guys have any more questions, pop on the Slack. I'm monitoring it. I'm liking the conversation that's going on though. So Donna is doing some cool stuff. I'm happy for it. And but if you have any questions about the Z proposal, reach out. I mean, a lot of people are thinking about it. So by all means, think about it together. And yeah, with that, good to see
Okay,
you guys.
thanks. Appreciate your time, John. Thanks.
I guess. All right.